Welcome back to Quantum X. In today's video, we're following a man with an unconventional idea, turning a multi-ton shipping container into his dream workshop right in his own backyard. If you love DIY, are drawn to unique creative spaces, or dream of building a workshop of your own, then stick around, because the journey of transforming a lifeless block of steel into the heart of creativity starts right now. The container is positioned at the rear corner of the new plot. Before the container arrives, the site is carefully prepared. Instead of pouring a concrete foundation, railway sleepers are placed in position as the base. This is a proven, practical solution. Sleepers distribute the container's weight evenly, lift the steel structure off the ground, and reduce corrosion from ground moisture. They also allow for adjustment over time if the ground settles. The real challenge begins at the very first step, delivery. As the truck approaches the site, the rear wheels lose traction while climbing the curb. The truck's undercarriage scrapes against the dirt slope, a clear sign that the entry angle and ground profile were not designed for the vehicle's wheelbase and load. The situation quickly becomes tense. The truck edges dangerously close to the neighbor's wall. With a fully loaded container and a limited turning radius, even a minor miscalculation could result in structural damage. This is a common issue on residential DIY sites where access roads were never intended for heavy container transport. In the end, the driver successfully unloads the container, but not in the intended position. It has to be placed further away. Before any modification begins, he decides to reposition the container to its originally planned location. The container is lifted incrementally using mechanical jacks, just high enough to slide round timber logs underneath. The logs act as rollers, reducing friction and allowing heavy loads to move without specialized equipment. But load distribution and alignment are critical. Any imbalance can cause the container to shift or roll unpredictably. A pickup truck provides the pulling force, connected with a rated steel chain. Slowly, the container is rolled backward toward the fence, inch by inch. The process is physically demanding and mentally tense. Here, control matters more than speed. In the end, the move is completed safely. No injuries, no damage. The container is pushed into its intended position and carefully lowered back onto its support piers, setting a stable foundation for the build to continue. The next phase focuses on insulation, one of the most critical steps in any steel container build. Without proper insulation, a container becomes unbearably hot during the day, cold at night, and highly prone to condensation. He chooses insulated panels combined with an InsoFast framing system designed specifically for metal structures. The InsoFast frames are installed across the container's walls and ceiling. They hold the insulation in place while creating built-in service cavities for wiring and ventilation. More importantly, the system introduces a thermal break, reducing direct heat transfer from the steel shell into the workspace. Instead of drilling and mechanically fastening through the container walls, a high-strength construction adhesive is used. This preserves the factory corrosion protection, minimizes thermal bridging, and reduces long-term rust risk. Adhesive installation demands clean surfaces, proper curing time, and even pressure to ensure reliable bond.
Structurally, InsoFast panels are rigid XPS insulation boards, but their key distinction lies in the integrated framing system. Molded directly within the foam are composite studs that act as load-bearing members, allowing interior finishes to be fastened directly without building a separate wall frame. This construction eliminates the need for traditional wood or metal framing, fewer materials, fewer steps, and most importantly, more usable interior space. In a shipping container, where width is limited, that saved space matters. Installation relies on high-strength adhesive, bonding the XPS panels directly to the steel container walls. Joints are sealed, and finishes are attached to the embedded studs. By avoiding steel penetration, the container's original corrosion protection remains intact, while thermal bridging and condensation risks are significantly reduced. From this design, the advantages follow naturally: faster installation, improved moisture resistance, high thermal efficiency, and long-term durability. For container-based DIY workshops, the system delivers practical performance without unnecessary complexity.
Before the adhesive fully cures, the InsoFast insulation panels must be held firmly in place. Temporary support braces are used to apply even pressure from the floor up, ensuring full contact between the panels and the steel ceiling. This method allows the adhesive to cure under stable conditions, preventing sagging, misalignment, or future separation. In a container build, even a small gap in the ceiling can lead to condensation and dripping directly into the workspace below. Once the adhesive has reached sufficient strength, every joint, seam, and gap is sealed. This step is not just about heat retention, it is about controlling moisture and unintended air movement. Insulation only performs as a system when it is continuous and airtight, especially in steel structures like shipping containers.
The container doors are insulated as well. This area is a known weak point: thin steel, multiple joints, and a high potential for heat loss. Insulation panels are carefully cut and fitted to the door surfaces, ensuring thermal continuity when the doors are closed and aligned with the surrounding walls. Before moving on to door installation, all foam debris and offcuts are thoroughly cleaned up. It's a small step, but a critical one. A clean work surface ensures proper sealing and accurate alignment during the next phase.
To ensure a stable sliding door installation, he builds a timber frame to act as an anchoring structure for the entire door system. In a container, the thin steel shell is not designed to handle concentrated loads from sliding tracks and repeated opening forces. The wood frame serves as an intermediary, distributing loads and providing a solid surface for fasteners. The frame is securely tied into the InSoFast system and reinforced points of the container, preventing forces from transferring directly into the steel skin. This reduces the risk of panel distortion, track misalignment, or long-term gaps developing around the door. Beyond load support, the timber frame allows precise vertical and horizontal alignment, essential for smooth operation and proper sealing. With glazed sliding doors, even minor misalignment can lead to air leakage or binding. This structural step is critical, setting the foundation for a durable, airtight, and reliable sliding door system. Although the container already has its original steel doors, he chooses to install an additional sliding door. This decision is driven by function, not aesthetics. Standard container doors are heavy and practical only for initial loading, not for frequent daily access. A sliding door provides a lighter, faster entry point for retrieving tools, materials, or finished work without opening the full steel doors. Because it operates on a sliding mechanism, it consumes minimal interior and exterior space, an important factor in a narrow container and a confined site. The glass sliding door also introduces natural light and improves ventilation, transforming a closed steel box into a more comfortable workspace. Beyond convenience and daylight, the sliding door plays a key role in thermal control. When properly installed and sealed, it helps retain heat during winter and prevents cooled air from escaping in summer. In the long term, this upgrade enhances usability, flexibility, and the overall working environment, key considerations in a container-based workshop. Once the drywall is fully installed, the next step begins, sealing every gap, joint, and screw hole with joint compound. This may look like a finishing task, but technically it is structural to the interior envelope. The compound ties individual panels into a single continuous surface, eliminating the last remaining air leakage points. Covering screw heads prevents stress cracking and reduces vibration transfer as the container expands and contracts with temperature changes. At panel joints, the compound helps distribute movement more evenly, improving long-term durability. In a sealed container environment, even small gaps can become sources of moisture intrusion or thermal bridging. This step ensures the interior envelope is truly airtight and stable, preparing the space for final finishes such as painting and fixture installation. What do you think of this project? Please leave a comment to let us know. Don't forget to like and subscribe to our channel to support us. Once the joint compound has fully cured, he he sands the entire drywall surface. The goal is not decoration, but uniformity. Sanding removes ridges at joints, high spots over screws, and surface imperfections that would later show through paint. From a technical standpoint, a flat surface allows paint to bond evenly and reduces weak points in the finish. This step also reveals any joints that need further attention, allowing corrections before final coating begins. Inside a container, light often hits surfaces at sharp angles, making imperfections more visible. Careful sanding ensures the workspace remains clean, consistent, and professional as the build reaches its final stages.
At one of the container's existing ventilation openings, he enlarges the cutout to install a dedicated exhaust fan for the workshop. Using an existing vent location minimizes structural modification and preserves the overall rigidity of the container shell. Once the opening is sized correctly, a steel frame is installed inside the cutout. This frame reinforces the cut edges, prevents deformation of the thin steel wall, and provides a solid mounting surface. The frame is securely fastened with screws, ensuring stability during continuous fan operation. Next, waterproof sealant is applied around the entire perimeter. This step is critical, blocking rainwater, moisture, and uncontrolled airflow from reaching the insulation layers inside. Finally, the ventilation fan is mounted in place. The system actively removes hot air, dust, and humidity, helping maintain a dry, stable, and comfortable environment. Essential for a shaping bay where extended work sessions are common.
Next, louvered ventilation openings are installed to work in combination with the exhaust fan. Unlike passive ventilation, this system operates actively. The electric fan forces air movement, rapidly expelling hot air, moisture, and odors from the sealed container. The louvered vents are positioned on the opposite side, acting as fresh air inlets. As the fan extracts air, internal pressure drops, drawing cooler outside air in through the louvers. This creates a continuous, controlled airflow loop. This configuration prevents stagnant air, especially important in a shaping bay, where heat, dust, and humidity build up quickly. Active ventilation not only improves working comfort, but also helps protect tools, materials, and the container structure itself from long-term moisture-related damage. Before painting begins, the floor is fully covered with cardboard sheets to protect the finished surface from paint drips. It's a simple preparation step, but one that prevents unnecessary cleanup later. A primer coat is applied first. Primer evens out the drywall surface, locks in fine dust from sanding, and provides a stable base for the finish coats. Once the surface is sealed, a gray paint is applied to the upper portion of the wall, keeping the workspace bright and visually neutral. Masking tape is then used to create a clean, precise boundary between the two colors. Using two tones on a single wall breaks the monotony of a solid color, adding visual depth and structure to the narrow container interior. By placing a lighter tone above and a darker tone below, the wall appears taller, subtly improving the sense of height and openness in the compact workshop space.
The next step is installing wall-mounted shelving to organize the workspace. Triangular steel brackets are fastened perpendicular to the wall, forming a stable shelf support system. The triangular geometry distributes loads efficiently, transferring forces directly into the wall and reducing bending moments compared to straight brackets. This helps prevent long-term sagging. The shelf surfaces are made from long timber planks placed on top of the brackets. Functionally, wall shelving frees up floor space and keeps circulation clear.
The final step is installing the shaping stand at the center of the main working area. This is the heart of the shaping bay, where the entire surfboard shaping process takes place. The stand is positioned along the central axis, leaving enough clearance for movement, rotation, and full visual access from all angles. From a technical perspective, the stand is securely anchored, with its height carefully set to reduce strain on the back and shoulders during long shaping sessions. A stable structure prevents vibration, which is critical for achieving accurate curves and clean outlines. In the final stages, the electrical system is installed to meet the demands of a real working shop. Steel electrical boxes are used instead of standard plastic ones, offering greater mechanical durability and better suitability for an environment with tools, dust, and constant movement. All wiring is routed inside steel conduits. This protects the cables from physical damage while reinforcing the solid industrial character of a creative workshop. What do you think of this project? Please leave a comment to let us know. Don't forget to like and subscribe to our channel to support us. Beneath the shelving, LED strip lighting is added, improving visibility at lower levels and introducing a subtle sense of visual depth. Switches and main lighting fixtures are installed to provide even illumination, minimizing shadows on shaping surfaces. Power outlets are positioned strategically around the space, allowing tools and equipment to be powered directly without cluttered extension cords. This electrical and lighting system balances functionality, safety, and aesthetics, bringing the container workshop to full operational readiness.
In the final finishing steps, the workshop is refined specifically for surfboard shaping. Overhead racks are installed to store finished boards and work-in-progress blanks. By moving storage upward, valuable floor space is cleared while reducing the risk of moisture exposure and accidental damage. A foam padding layer is added around the steel support frame at the main shaping area. It's a small detail, but a critical one in surfboard production. During rotation, applied pressure and fine adjustments, even minor contact with a rigid steel edge can dent or chip the board. The foam acts as a shock-absorbing buffer, reducing impact forces from accidental contact. More importantly, it allows the shaper to work faster and with greater confidence without constantly worrying about damaging the board. This is a practical solution, commonly seen in professional shaping bays where precision and efficiency go hand in hand. Next, a large-capacity dust extraction system is added, a critical component in any shaping bay. Fine foam and composite dust do more than compromise surface quality. If left uncontrolled, they pose serious health risks. Active dust collection keeps the air clean, maintains visibility, and ensures the workspace remains consistently usable. Finally, an air conditioning unit is installed to regulate temperature. Inside a sealed steel container, stable thermal conditions are essential, allowing adhesives, resins, and shaping materials to behave predictably, while also supporting year-round comfort and productivity. From a raw shipping container, he has built a fully functional shaping bay where every detail serves durability, efficiency, and long-term use. This is more than a DIY build. It reflects a clear understanding of materials, structure, and real-world production. If you found this project valuable, leave a comment and share your thoughts. Don't forget to like the video,
share it with others, and subscribe to the channel for more container builds and creative workshops. Thank you for watching until the end.